Okay, so number 17 says we're going to take the integral from 1 to 4 of the integral from 1 to 2 of x over y plus y over x dy dx. Okay, and I've gone ahead and I've highlighted that inside part. So we're taking with respect to y. Okay, so when I look at this, the first thing that you kind of think that we should do here is we rewrite this, okay? And we're okay with the 1 to 4, 1 to 2. And your first thought is, okay, well, I'm going to make those fractions. I'm going to take those variables up to the numerator. So I really have x negative 1 y dy dx, okay? Now, that's okay for that x to the negative 1, but this y to the negative 1, since we're taking with respect to y, if you will remember, there's a property when you took derivatives. If I give you y equals the natural log of x, and I tell you to find the derivative or to find y prime, the derivative of the natural log of x is 1 over x. Okay? So what we really had here, and I'm being a little redundant, but I just want to make sure you see it, is when I had x times 1 over y, because that's what x over y is, plus that x to the negative 1y dy dx will be more easily evaluated if I leave that as 1 over y, because we are taking with respect to y. So this winds up becoming, well, that x in this particular case now is a constant because we're taking with respect to x. So with respect to y. So I merely just write down the x. That's like a 2. That's the natural log of y. And I'm actually going to move this down a little bit. And I have, of course, my integral from 1 to 4 here. And then I have plus, well, we can leave that x negative 1. That's fine because it's just a constant there. And then I've got y squared because I add 1 to the exponent, divide by the new exponent. And I'm evaluating that from 1 to 2 dx. Okay? Now, everywhere I see a y, I'm going to put in 2. Then I'm going to subtract. And everywhere I see a y, I'm going to put in 1. So I have my 1 to 4 there, of course. And that's going to give me x natural log of 2 plus, I'm going to go ahead and move that x back to the bottom. So that's 2x. And then I've got 2 squared. Okay. Minus, I have x natural log of 1 plus, I'm going to go ahead and move that 2x back to the bottom, the x back to the bottom. And I have 1 squared. Okay, so this natural log of 1 right here, that actually is 0 because it's asking us e to the what equals 1. And the only way to get 1 from an exponent, well, other than 1 to the something, is going to be 2 to the 0 is 1, e to the 0 is 1, 3 to the 0 is 1, that kind of thing. That's why that makes 0. Okay, so, whoops, got my dx. And that gives me 1 to 4, and I've got x, natural log of 2, plus, well, that's 4 over 2, so that's 2 over x. That made 0, and then I've got 1 minus 1 over 2x dx. Now I'm ready to take the integral of that, okay, with respect to x this time. So that natural log this time is just going to be like a constant. That's x to the first power, so he was x squared. Divide that by 2. Once again, we have this right here is really the same thing as saying 2 times 1 over x. So that's going to give me plus 2 natural log of x, because the derivative of the natural log of x is 1 over x, minus, and then this one is really the same thing as negative 1/2 times 1 over x. So I can write that negative 1/2 down because it's a constant. And then when I take the derivative of it, gives me 1 over x. That's the natural log of x. Okay, and we are going to evaluate that from 1 to 4. Okay, so this means I'm going to have 4 squared natural log of 2 over 2 plus 2 times the natural log of 4 minus 1/2 times the natural log of 4 minus 1 squared natural log of 2 over 2 plus 2 times the natural log of 1 minus 1/2 times the natural log of 1. Okay, well, as we stated before, the things that have natural log of 1 in it, they're going to zero out. That does help us a little bit. That gives me 16 natural log of 2 over 2, which gives me 8 natural log of 2 plus 2 natural log of 4 minus 1/2 natural log of 4. And then all of that is minus natural log of 2 over 2. The first thing I will do is put those natural logs of 2 together. So I'm going to kind of go back a little bit. So that gives me 16 natural log of 2 over 2 minus the natural log of 2 over 2. Okay, and then I'm going to put the natural log of 4's together plus 4 natural log of 4 over 2. All I did was get a common denominator here, minus 1/2 natural log of 4. Okay, when I put that together, that's going to wind up giving me 15 natural log of 2 over 2 and plus 3 natural log of 4 over 2. These will actually combine more. We can't do anything with that 15 natural log of 2 over 2, but this becomes 3 natural log of 2 squared over 2. And if you'll remember your properties of exponents, when you have a log or a natural log and you have that exponent on whatever you're taking the log of, it can come to the front. So that's going to give me 15 natural log of 2 over 2 plus 6 natural log of 2 over 2. And that's going to give me 21 natural log of 2 over 2.